The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Amazing Mechatronics, Young Engineers of Today. We're going to continue with Scratch. I hope everybody had a good couple of days, but we're going to jump right into creating an entirely new, let's see here. Yeah, we're going to jump right into creating an entirely new program. We're going to, yes, they've been posted on YouTube already. Or, well, this one has already been posted on YouTube. You can actually find it under the Young Engineers of Today. If you just do a search, the YouTube channel, it's going to have a picture of a couple of Young Engineers attendees in years past, and also the Young Engineers of Today logo on it. And as you can see, here's Tuesday's lesson, the recording for it up. But yeah, so we're going to continue with Scratch and make as much progress on our first challenge as we can today. I'm going to walk through sort of why we're doing everything we're doing, which means, yeah, things are going to go maybe a little bit slowly, but we'll get through everything, and hopefully by the end of it, you guys will understand exactly why we're doing all of the stuff that we do. So I'm going to pop over to scratch.mit.edu, just like we did in the previous lesson, and get signed in. So I'm already logged in, just because I've been signed in the past and everything. And then I'm going to go ahead and click on Create. Just go ahead and, yeah. I'm going to go ahead and just make sure everybody's on the same page. Raise your hand once you've gotten Scratch started up. Why is it? There we go. Give everybody a few more, like 30 more seconds to get that started up, and then we'll get started. Perfect. If you have, just go ahead and raise your hand. All right, well, that's just about everybody. So let's get started. If you're still getting it open, no worries. I'm going to spend a little bit of time talking about this. We're getting Scratch started up because we're going to make a small game. We're going to make one-player Pong from scratch. No pun intended. Okay, so first things first is, well, we're going to get rid of the cat sprite. And there's a reason for that, which I'm actually going to walk through just really quickly. No, we can hit that up later. But for now, just if you right click on the cat sprite and click on delete, he'll go away. But that's exactly what we want to do right now. We want to get rid of the cat sprite so we have a completely clear backdrop. Once that's done, we're going to add a couple of new sprites. First one we're going to add is a ball of some description. Some kind of sports ball. So we can do like a beach ball or just a regular ball or a soccer ball or a baseball. I'm going to go with let's say the beach ball. and hit OK. So now we're going to have a beach ball, and it's going to be hanging out here on our canvas. And then I'm going to add a new sprite. And let's scroll through all these different options. There's a whole bunch of different options. See, you've got if you can't, if you don't upload something of your own, you've got plenty to work with already anyway. The second thing I'm going to upload is the trampoline. So we got the trampoline and the beach ball, and these are going to be our two sprites. So make sure you got both of those there. Now, in this very simple Pong game, what's basically going to happen is the ball is going to bounce along the top and side walls, and we want to keep it from hitting the bottom. We don't want it to hit the bottom at all, otherwise we lose. We're going to be controlling the trampoline along the bottom. If the trampoline hits the beach ball, it's going to bounce off of it and keep going. If the trampoline allows the beach ball to get past, the game's going to end. Each time the ball bounces off the trampoline, we're going to get a point. And so the whole idea is just to get as many points as possible. With that in mind, I'm going to go ahead and move the beach ball roughly to the center. Doesn't have to be exact. And I'm going to move the trampoline to the bottom underneath it. Seems pretty straightforward. So now what we need to do is we need to set up the behaviors of everything that we're going to work with. Now, the beach ball, based on the way we're going to structure this program, is probably going to be a little bit more complex than the trampoline. And that's because we're going to have a few sort of interactions that we're going to need to keep track of. So let me pull those up so I can describe them. Remember when we talked about how we needed to make things as simple as possible for a computer to understand? So if we describe our program like ball bounces on trampoline, keep ball from passing trampoline and walls. That seems pretty simple to us, right? I mean, you get the idea of the program, but believe it or not, this is still not simple enough for a computer. We need to go simpler than this. So let's see what else we can do here. Player controls trampoline. Ball bounces on trampoline and walls. If ball passes trampoline, game ends. If ball bounces on trampoline, game continues. And player gets points. This is a little bit better. It's a little bit better, but we could probably still do a little bit better than this. Let's see here. Player controls trampoline with mouse. Trampoline moves to mouse position. All right. Ball bounces on walls and trampoline at right angles. That may not make any sense to you right now, but that's okay. It will in a minute. Ball cannot go into game over zone. If ball hits trampoline, give player points. So this is more or less the same as what we've got up here, which is more or less the same as what we got up here. It's just more descriptive. So now we're getting to the point where we can describe how a program might look to us before we start building it for a computer. This is just a very, 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 very sort of simplified look at how we might want to structure the program. So let's try working with this. As you can see, the description of the ball is a little bit longer than the description of the trampoline. So let's try coding the trampoline first. So the player controls the trampoline with the mouse, and the trampoline moves to mouse position. This is almost like saying the same thing twice, but there's a little bit more description here, because when we say player controls trampoline with mouse, we might say, oh, maybe the player has to click in order to move the trampoline, maybe the player has to drag it. You know, these are the things that we can assume, but the computer cannot. So we have to be a little bit more explicit in saying that the trampoline moves to mouse position. Even then, I could do a little bit better in saying, you know, the player, no mouse clicks or keyboard input is accepted. So like the player can't use the left and right arrow keys. They don't have to click and drag, stuff like that. In fact, it'll be ignored. But we'll say that this is good enough for now, because this is just for us to keep track of. So the player controls the trampoline with the mouse, and the trampoline moves to mouse position. All right, so let's start controlling the trampoline. Now, this is why I had you guys delete the cat sprite, because the way Scratch is structured is it puts code inside of these sprites. These are sort of considered to be separate little boxes that hold on to scripts from Scratch. So let's see here. So I've got the beach ball selected, and let me just drag in a bunch of code. I'm going to stick this in there and attach this to this and put this right here and put the pen down here and set the pen color and then turn everything 15 degrees and point towards the mouse pointer. And so now I've got some Scratch, right? Now watch what happens when I click on the trampoline. Boop, it's not there, because all of this that I just put in here, which I'm going to delete. You don't have to do any of this. This is just for an illustration. All of this only applies to the ball because we've put all this code in here where the ball is selected. So that's all going to control the ball. Now there's nothing controlling the ball because I deleted it, but it was all garbage anyway. If we want to control the trampoline, if we want to set up a code to control the trampoline, we want to make sure that the trampoline is selected, because now that the trampoline is selected, anything we put in here is going to apply to the trampoline and not to the ball. So let's go ahead and get this started. So if we want to set the trampoline to be the mouse position, we might say go to mouse pointer. And we can just test this out. If we get started. See now, as soon as I clicked, it went to where my mouse pointer was and it flew right up there. So, oops, stop. Okay, let's delete the code again. So there we go. Now my trampoline is cooperating with me again. So go to mouse pointer is close, but it's not quite there. We need to be a little bit more explicit than that, because we want to make sure that the trampoline doesn't move up or down at all. We want to make sure that the trampoline just stays at the bottom and moves left and right. Now, you remember what I was saying yesterday about the X and Y here that correspond to sort of the different positions on the canvas? If we wanted to make sure that the trampoline didn't move up or down, which of those two values do we want to make sure stays the same? And you can move your mouse around on the canvas and see how the X and Y change, just to get an idea of maybe which one should change and which one should stay the same. Okay, so we got to vote for Y should stay the same. Do you guys agree? I got another vote for the Y-axis. Yeah, exactly. So yeah, that's it. You want to make sure that Y stays the same and only X changes. This go to mouse pointer, it's close, but it changes both the X and the Y of the, yeah, exactly, another y-axis vote. It changes both the x and the y of the trampoline in order to get it to where the mouse pointer is. So this is close, but it's not quite what we want. If we keep looking, we see, hey, we got change x by y, or by, excuse me, why did I say that? Change x by 10, set x to 0, change y by 10, and set y to 0. So now there are actually some bits of code that exist in Scratch that refer to only one of the axes. Now, when it says something like this, it's sort of assumed, I guess, that the other axis will stay the same because it's not being changed. Because again, computers are dumb. Unless you tell it to change it, it won't. So what we want to do is we want to set the x. Changing the x is close, but changing the x makes things a little bit wonky because it will it has to do more with changing how the trampoline moves as opposed to setting the trampoline in a specific position, which is sort of a confusing concept at first. But after the class, if you're curious, you can always play around with it and change x by 10 instead of set x by, or excuse me, change x by a certain value instead of set x by a certain value, and see how that affects things. So what we're going to do is we're going to drag out the set x2, and all that is meant to do is just set the x value to a specific number. And we want to take in mouse input. Now we can't use the goto mouse pointer here because that's just another command. That's not really going to do us any good. So what we want to do is we want to check out maybe sensing. Because remember, sensing is all of our input stuff. So as you can see, touching mouse pointer, touching color, color is touching color, distance to mouse pointer, ask what is your name and weight, answer, key space press, mouse down, mouse X, mouse Y, loudness, all these different things. Now, if we're only changing the X position of the trampoline, what do you think we're going to use to change that X position? It's going to be the mouse, but that narrows it down to these three things. What do you think it's going to be? Yep, that is exactly it. We're going to be affecting the X of the trampoline by mouse X. Yeah, exactly. So one of the really nice handy things about Scratch, which you guys probably already know if you're familiar with it, is this doesn't really attach to anything traditionally. What it does is it goes into the text box here. So if I mouse over the text box with this mouse X, you'll notice that the text box lights up. If I drop it in there, it slots in. So now we can read this statement in plain English. Well, plainish English. Set X to mouse X. So if I click the green flag again, nothing happens because I'm a dingling and I forgot to put my green flag here. If I click the green flag, look at that. The trampoline immediately sets its X position to my mouse's X position. It only does it once though. If I click the green flag, it doesn't continue to do that, which is not quite ideal. But what do you think is going to make sure that this is always setting X to mouse X? Remember last time we were talking about something that continually makes a program run forever and ever and ever. Yeah, it's going to be a repeat loop. Exactly. We're going to be repeating it. And if we want to repeat it forever, we're probably going to use a forever loop. So let's go ahead and slot that in there, and we'll hit the green flag. And sure enough, if I move the mouse around, the trampoline keeps pace with it. In fact, the trampoline can move super duper fast because I can turn up the sensitivity of my mouse and just wig out, and the trampoline dutifully keeps up because computers are dumb, but they're really fast. Faster than I am, that's for sure. So just to repeat this, whenever the green flag is clicked, for as long as this program is running, set X to mouse X. And that's it. That's what this trampoline does is it sets the X position of the trampoline to the X position of the mouse forever and ever and ever and ever and ever until we click the, the red stop sign, the red octagon. Or is that's a hexagon? That's an octagon. I can count. Yeah, super easy to do. So that right there has solved this problem. Player controls trampoline with mouse, and trampoline moves to mouse position. Boom, done. We can just go, bap, gone. Actually, we can get rid of all this other stuff. But that does leave a little bit more complex stuff. Ball bounces on walls and trampoline at right angles. Ball cannot go into game over zone. If ball hits trampoline, give player points. Well, we can at least get the ball to start bouncing. Now, remember, we have to start putting that code into the ball. So we have to click on the ball in order to get it to, take the code that we're giving it. Okay. So what we're going to do is we're going to say, let's see here. Well, I guess that's easy enough. If on edge bounce and move 10 steps. And what that's going to do is it's going to make the ball move forward 10 steps in whatever direction it's facing. And if it hits the edge of the screen, it's going to bounce. Now, this is a surprising amount of code that's all just being compressed into one step. But it gives us a good idea of what's going on. Now we just need to wrap this into a forever loop, like we did for the trampoline, so that it always does it, and set it up so that it starts when the green flag is clicked. And let's test it out. Look at that. 2 commands set to repeat forever, and the ball is suddenly bouncing off walls. Just like that. However, no matter what, our ball only bounces left and right. Now, there's a reason for that. Oops. And that's because this move 10 steps always tells whatever the sprite is to move towards the direction it's facing. And that's harder to see with the fact that this is a round object. But let me draw some arrows on it, because that's always fun, right? So this ball very clearly has a front and a back. So the green is the front and the purple is the back. Whenever we say we want it to move 10 steps, we're telling it to move forward 10 steps. Oh man, look at that writing. We're telling it to move forward 10 steps. Whenever it hits a wall, what happens when you show of hands, how many of you have played something like pool or caroms or heck, even just like soccer or something like that? Ah, yes, good old caroms. I used to play that all the time when I was around your age. Yeah, so if you guys know what happens whenever a carom or a pool ball or whatever hits the wall of the thing. Let's say it's coming at it like this, and it kind of goes doink, and it heads off in a very specific direction. Yeah, it rebounds. If you hit it straight on, it goes doink, and it starts coming back in the same direction it went into it. If you hit it like just straight onto the wall as opposed to like at an angle like it's here. So that's exactly what's happening here, is the front of it hits and then it starts going in the other direction. The computer cheats a little bit in doing this. What it does is it says, okay, because the ball is always moving forwards. What it does when it hits this point is it just changes the direction that forward is for the ball. It rotates it so that forward is facing in the direction that it should be going. In fact, if we set this to be the cat, Oh no, that's the wrong thing. We can. But if we set this to be the cat, you would actually see the cat flip and face the other direction when it started heading back this way. It'd hit the wall and flip in the other direction and head back this way. So it would sort of be doing like this walking back and forth kind of a thing. So that's what's going on here, is the computer's just saying, hey, so the front's always going to be the direction that it's moving. The front now is going in the opposite direction so that it can continue to move forward. So whenever we say move 10 steps, it's always going to be moving forward. What we need to do is we need to vary things a little bit. We need to make sure that the ball kind of goes in a more random direction whenever it starts, because otherwise it's always going to hit it at a 90-degree angle, or excuse me, yeah, at a 90-degree angle to the wall, and it's going to flip 180 degrees or flip in the other direction and head back in the same direction it came. And it's just going to do this forever and ever and ever because we have not introduced any sort of random effect to it. When we do this in real life, it doesn't always bounce straight back. And there are a whole bunch of reasons for that. We're not hitting it against a perfectly flat surface. So there might be a slight curve to it or something like that, which causes the ball to sort of not hit it straight on and maybe not bounce straight off. Maybe it looked straight, like we were hitting it straight on and didn't quite do it. Um, there are sort of like the way we can hit it can kind of create a wobble in the ball. There are literally just a bazillion. I say literally, and then I use a fake number like a bazillion. But there are a bazillion different things that could sort of influence it so it doesn't bounce straight back. This is not representing that, so we're always going to see it bounce back and forth. So let's add a little bit of randomness in it. So what we're going to say is we're going to have it turn 45 degrees counterclockwise, or excuse me, clockwise before it starts. So that's going to be the one that makes the arrow point towards the right. So it's going to be turning 15 degrees, or excuse me, 45 degrees clockwise before we even start. And we should see it reflected here on the ball. The ball is going to start heading up this direction, if I remember right. I believe it was, let me say that this way. I believe the ball was heading this way. If the ball was heading this way, then we'll see the ball start going this way. If the ball, in fact, was heading this way, we'll see it start by going that way. So let's see which one it was. I'm going to go ahead and hit start. Yep, there it goes. And now see, it's bouncing off at an angle. So now there's a lot more sort of randomness in where the ball's going to go. I say randomness, it's still not entirely random. I mean, this is all, it's always going to bounce at a 90, like at a 45 degree angle to the wall, and it's going to head at a 90-degree angle to its new direction. It's very, when you start doing like geometry and stuff like that, you'll probably cover stuff like this, like angles and things like that. And if you aren't already doing geometry, and this will all make a lot of sense. But as it stands right now, it looks a lot better. However, it's not quite there. It ignores the trampoline. It doesn't want to touch the trampoline. It just kind of goes through it like it doesn't exist. Because we have not gotten to that part where we explain that the ball bounces on the trampoline. And what happens when it hits the trampoline. So far, we're close. We also, just as a general rule, probably want to stick this in here, the go to X, Y, and set it to 0, 0. Now, every time we restart the game, the ball will restart in the middle. That way, if we lose the game, like we let the ball get past, or we just have to stop for a while, the ball won't pick up where it left off, which can be a problem if it was in the game over zone, because if we start it up again and it's still in the game over zone, you'll just lose again immediately. And you'll have to keep doing that until eventually the ball, because it'll always just move like a little tiny bit each time until the ball is finally out of the game over zone, and then you can play the game as normal. In the interest of keeping things much more consistent, we're just going to have the ball restart in the center each time. Yeah, well, we can do that in a minute. Now, we're going to do something a little weird here. We're going to bring in another control, but it's not going to be a loop. It's going to be this if blank then. This if blank then is referred to as an if statement because people who write computer code are super good at naming things. Now, an if statement is a part of something with a really kind of fancy name called control flow. So imagine, you will, a world in which computers had programs that had no if statements. It'd be like watching movies, because no matter how many times you watch a movie, the same thing happens. You might be watching a horror movie, and the people go, hey, or Scooby-Doo or something like that, and they go, hey, let's split up. And you might yell at the TV, no, don't split up. That's the worst idea ever. But it's a movie or a TV show, and they can't hear you. You have no input on it. So no matter how many times you yell at the TV, no matter how loud you yell at the TV, they're still going to split up, and everything's still going to go as it does. This is like a computer program without if statements. It's not going to really take any input from us while the program is running. Now I say that, and we've got this we've got this forever set x to mouse x. But for the sake of argument, there's no capability for a program to do something from one loop to the next. There's no capability for the program to change while it's running. And an if statement allows you to do that. These things are magical. Loops, if statements, variables, these are all sort of the bread and butter of a programmer. With these three things, you can make pretty much anything. Now, I say pretty much, there are going to be programs that are just going to be very, very complicated, and you'll need sort of higher control flow. That's the fancy term for it. Which is sort of weird that it's called that. I feel like it's backwards. But anyway, you might think it'd be called flow control. But anyway, train of thought, coming back into the station. Give me a sec. Yeah, you might be able to write larger programs using these things, but you'd have a hard time. And you need to leverage sort of fancier computer science concepts in order to more easily write larger programs. However, the foundation of those fancier computer concepts tend to just use if statements, variables, and loops. For sure, no problem. So, worry not. What you guys are learning today is sort of the bedrock of computer programming, no matter how far up you go. Now, the other thing is you can go in the other direction and go further down and start doing assembly and stuff like that and find out that this is sort of like a molecule to the atoms of assembly, but yeah, we don't have to worry about that. Just know for now that these are the foundations of a programmer's arsenal. So what we're going to do is we're going to throw an if statement in here, and it's going to be attached to the bottom here, because we always want it to bounce if it's on an edge, and we always want it to move 10 steps. Always, 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 always. However, we want it to do something a little bit different when it hits the trampoline. So we're going to go back to our wonderful sensing category, because again, this is input to our output. And we're going to ask if it's touching something. We're going to ask if it's touching the trampoline. As you can see, you can select the trampoline from the drop-down list of the touching category and slot it into here. Notice how the if statements have these sort of hexagonal little slots in them, and the sensing is the same shape. Now, there are a couple other ones. I can say if some of these have similar shapes here, but for now we're going to pay attention to the fact that the sensing has the same shape. So it would sort of stand to reason that it fits in there, right? That this fits with the if statement. So if touching trampoline, then we want it to do some stuff. So what we're going to have it do is we're going to have it turn and, oh, interesting. So we're going to have it point in direction 0 and then turn 15 degrees. Now, if we do this and we hit play, we'll notice, oh boy, this is part of the problem. There we go. If we do this and we hit play, we'll notice that it bounces off the trampoline. However, it always, always, always bounces off the trampoline in the same direction. Also, you may notice if you click play a few times, well, it doesn't really do it anymore. That for a while there, the ball was always heading in a 90-degree, where not always, but it was always moving in 45-degree increments, and at one point it could get stuck bouncing back and forth again, and you just had to restart it. We could do a little bit with that, but we're going to do something a little wonky here with this turn 15 degrees. We're not going to have it just turn 15 degrees. We're going to go over here to operators, because there's something here in operators that allows us to do something that's very sort of useful with computers. There's this option right here, pick random 1 to 10. I'm going to slot that right into this turn 15 degrees. Except I'm going to change the numbers from 1 to negative 15. Oh dear. Getting a call from Mobile, Alabama. Okay. I'm going to pick a random direction from negative 15 to positive 15. And so what this is going to do is this is just going to pick a number completely at random. Oh, wait, that should be positive 15. I wrote negative again. So negative 15 to positive 15. So it's going to pick a number, a whole number between negative 15 and positive 15. What does this mean for us? So it's going to point in, it's going to point straight up, and then it's going to pick a direction between this and this. And it's going to pick something somewhere in here. So, in essence, the ball might head this way at one point when it bounces, and then it might head straight up. And then the next time you hit it, it might head like a little bit off to the side, and then it might head back this way, and then it might head over here. So it gives us a little bit of randomness to where the ball is going to bounce. So let's test that out. Doink, doink. See, look at that. Now the ball is actually heading back, and now it's heading in the other direction. So there's a little bit of randomness to it now. We can make it harder by making this angle wider, by making this number, this range of numbers larger. So let's do negative 45 to 45 and see what happens. Now the ball shoots off in a direction sometimes, totally at random. Sometimes it stays pretty mild and just sort of bounces up and down, and then sometimes it goes off somewhere else and you really have to move the paddle or the trampoline in order to be able to hit it. How do you make the ball go faster? Ooh, that's an excellent question. I'm actually going to pose that to you guys. How do you make the ball go faster? Think of how the ball actually moves. What makes it move forward? And how do you change that? What do you guys think? Okay, so we got a glide motion vote. Somebody else said go to motions. I'll give you a hint. The answer already exists in your code for the ball. There's something you'd have to change, but you wouldn't have to drag anything new over from the palette. Yep, that's it. You change the amount of steps. Um, because here's the thing. Every time the program runs one cycle, it has it move 10 steps. Yeah, what if we had it move, well, let's say 25 steps and hit play? Now the ball's just shooting around everywhere. Conversely, if we had it move 5 steps, now the ball's super slow. This game is so hard. There's plenty of time to just sort of. I actually stopped paying attention to the game for a second and then came back in time to move the trampoline underneath the ball. So yeah, that's how you would change the difficulty of your game, is by changing the number for steps. How do you increase ball speed as the game progresses? Ooh, excellent question. All right, so that starts dealing with the third, I guess, sort of tent pole of programming, and that's variables. And we're actually going to address that hopefully in just a minute here. Can you make the ball go different speeds at different times? Yes, you could actually do that too. So we've already got adding a random number here, adding a losing element. So yeah, making the ball go different speeds at different times would again correspond to this random element here. We could say something like, instead of move 10 steps, we could have it pick random from 1 to 10. This is going to change very quickly from each cycle. So the ball is going to move strangely. Now it's got kind of like a stuttering motion because it's changing each loop, which is a little bit too often for it to be updating. But we could see that. So let's go ahead and drag that back out. In fact, we could do something really wacky. Instead of 1 to 10, we could do 1 to 100 and watch it just flip out. Now it just seems like it's moving really fast, but there will be points where the ball just sort of stops in place for a moment because it's got a really low speed. But it does create a pretty challenging game. It's like like somebody trying to fake you out and they're pretending to throw the ball and they don't actually. What about the score? Okay, so let's start touching on the winning and losing conditions. Because right now what we have is a toy, not necessarily a game. I know that there are a lot of people out there who are around my age. I say a lot of people. There are a fair amount of people out there who would have an argument all day about what makes a game. But I'm just going to go ahead and I'm going to say this right now for the sake of argument for our class. In order to make a game, we're going to need a winning condition and a losing condition. Otherwise, it's a toy. So what I'm going to do is I'm going to start by creating the losing condition because I'm mean like that. And then we will talk about creating the winning condition. We may not actually get started on creating the winning condition until next class, just looking at the time right now. However, if we get the losing condition in, I could spend a little bit of time talking about the win condition. And the win condition will actually be our introduction to variables. Then, once we have variables sort of locked down and we're comfortable with them, then we can start doing things like making the ball go faster or change speeds, stuff like that. So once we have variables, you can really start to open the door as far as changing the flavor of your game. Man, sometimes words are hard. It will be, yeah, definitely. So we're going to do something a little bit different here. You'll notice that our if touching trampoline has been wrapped up into our if on edge bounce and move 10 steps. We're actually going to yank that out. Whoops. And we're going to keep this separate from the other thing. Well, that's strange, you might be saying. Why would you do something like that? Well, by doing this, by splitting these up into two separate things, both of these codes now run at the same time. Because remember, Scratch runs from top to bottom. If we stick this back in here, let's do this. If we stick this back in here, it's going to check if it's touching the trampoline first, and then it's going to say if it's on the edge, bounce, and then it's going to say move 10 steps. If we add a losing condition, and we stick it maybe underneath the 10 steps, well, then the game will still have the ball move 10 steps before you actually lose the game, which is not quite ideal. So if we have these two in separate things, they'll both be running at the same time. So let's add another if statement. But we don't know what to do with it. If, let's see here, if touching mouse pointer, if touching color, if color is touching color, if distance to mouse pointer, if ask what's your name and wait, if answer, if key space pressed, if mouse down, mouse X, mouse Y, mouse loudness, why did I say that? If loudness, if video motion on the sprite, if turn video on, if set video transparency, if timer, reset timer, exposition of trampoline, current minute, days since 2000, and username. Some of these don't really seem to work out so hot. If days since 2000, let's say if days since 2000. So if it happens to be January 11th, 2018, you're just going to lose. Always. Sorry, you can't play this game until it's January 12th. That doesn't really seem to fit with ours. If timer, okay, interesting, but we don't have a timer-based game. We want to make sure that the ball doesn't touch down here. If loudness, you lose if you scream at your game. If let's see here, if username, if you have specific usernames, you just lose. None of these really seem to fit the bill. Although we got an intriguing one up here, if touching color. Because here's the thing. We can make our own sprite that's a certain color. So what I'm going to do is I want to pick this deep, deep red. And I'm going to walk back a second and actually explain how I got here. So we'll go back to scripts. And I'm going to click on the little paintbrush here, which is labeled Paint New Sprite. And I'm going to click that, and I get this screen here. Now, if I select this red and the rectangle over here, I can draw a rectangle. And actually, I want to fill it up with that color as well. So it's going to be a solid red like that. So this is a very, 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 very red color. And that's perfect. That's what I want. So with that done, I'm going to click over here on scripts, and then I'm just going to kind of click and drag. Oh, actually, if I go back to costumes, I want to make this larger. Well, I may have spoken too soon. All right, so I'm going to draw it larger. I'm going to draw it actually as large as the entire canvas. And again, I'm going to make it red, and I'm going to paint bucket it so that it's red. And now, as you can see, the whole bottom area is filled with red. I'll move the trampoline in front. And I'm going to select the beach ball again. And this is still... it's just about large enough if I drag it over. I'm going to select the beach ball, and look at that. If touching color, and if I click on the color, my cursor turns into a pointer finger, and whenever I mouse over, the color changes inside the little box. Now it's looking for a color. All I have to do is put my pointer over this little red area, click, and now it's touching color red, and it's going to be this exact red. And I'm going to put it in here. So if touching color red, then we can go up to control, and there's this one right here. Stop all. Boop. Drop that right in there. Now, we've got a Pong game because it can bounce, well, almost, still almost, because it can bounce. We got a Pong toy that you can lose. It can bounce, but if it doesn't hit the trampoline, everything stops. Well, if it hits the red area, everything stops. So things are getting a little bit more interesting. Well, I'm going to go ahead and I'm going to save this. So it was Progamers am div a. Go up here to File and hit Save Now. And so now, if we want to reference this in the future, it will be saved. So you guys can do that at home as well. So just give it a name. In touching color sensor again? Yeah, sure. So if you just click the little square in touching color, your cursor turns into a pointer finger. And then if you mouse over whatever and just watch the little color square, it changes depending upon whatever you're mousing over. So if I mouse over the red and I click, then it sticks. For sure. No problem. All right. So it is 6:53. What I'm going to do is I'm going to start doing the poll questions. And I'm going to leave it open for question and answer time until about 2 till, because I got to get prepped for my next class as well, which starts at 7. So we'll try and get through this as quickly as possible, just so you guys have as much time as possible to ask me questions before we move along. And then if you don't have any questions after we do the poll questions, you're more than welcome to head out. Have a wonderful weekend, and I will see you on Tuesday.